So apart from changing temperature, matlab apart from like heating or cooling, another way you can change solids, liquid, gases is by changing the pressure. Okay. Before we get into the change of state, what do you guys understand by the word pressure? What do you know about it, abhi tak, if you have learned about it pehle? Yeah, Shanaya, tell me.
Pressure is the force exerted per unit area. So
Absolutely.
it is mass by the area.
Correct. Mass nahi, but yes. So pressure is force exerted per unit area. So pressure is a form of force, like how much you're pushing it by, but pressure will give you additional information. It is so if I have an object here, I'm pushing this with my whole palm this way, versus if I'm pushing it with only a single finger this way. Which will like hurt more? Which am I going to feel more? Full palm or just my finger?
Miss hurt more.
Yeah,
Finger.
because even though I'm pushing with the same force per unit area, like ये पूरा force ये पूरा area पे distribute हो रहा है ना, but if I'm doing it with a single finger, all of the force is applied only at a single, like ये छोटा सा point. So that's the kind of information that pressure will give you. So that's why force per unit area is important. Okay. And also pressure is useful for us when in a very general sense, like if we can't like if it's a large amount of area, like for example, you guys must have come across atmospheric pressure, right? Do you know what is atmospheric pressure?
Pressure
pressure
exerted.
by the air.
Yes, it is the pressure exerted by the air around us. Like you don't feel it because humans evolved to like, this is natural, this is default state. But sometimes you do feel it. Like when wind blows by, you can kind of feel the wind against your skin, right? So that's like tiny changes in pressure, and that's basically your atmospheric pressure. Now, it is impossible to calculate the total force exerted by all the gas around the earth, which is why we talk about it in terms of pressure. It's just easier and more convenient that way. Now, how is this relevant to our solid liquid gas? So let's get back to solid liquid gas के particles कैसे हैं. So solid में the particles are arranged close to each other, very rigid. Liquid में they are kind of close to each other, but they are still able to move. थोड़ा extra distance है particles के बीच में. And in gases, they're pretty far away from each other. Okay, so now we are changing the pressure at which this particular matter, this particular object is at. So if I increase the pressure on a gas, so increased pressure matlab I'm compressing the gas. So what do you think will happen to the gas? Imagine box hai gas ka, and I'm like increasing the pressure. So I'm like pressing all the particles closer together. So what will happen to the gas? Yeah, Suhani, can you repeat that?
It will turn into liquid.
Yes. So space hai, but if I'm like pressing it closer together, all these particles are forced to come closer to each other.
Intermolecular spaces reduce.
Yes, decrease. Pressure zyada hai, so spaces decrease ho jayega. So when they're coming closer to each other, the gas turns into liquid. Okay. So gas turning into liquid, opposite ho raha hai with increase in the pressure. So similarly, liquid pe, if you further increase the pressure, If you try to compress liquid, this is going to turn into solid. So iska bilkul reverse. So if I decrease the pressure, so this is I'm talking about increasing the pressure on it. If I decrease the pressure, if I increase the space around it, pura vacuum bhar jayega. Like vacuum is basically absence of everything. So if there's extra space, the particles will, like they will have a tendency to move away from each other. So decreasing the pressure, if I decrease pressure on a solid, it will turn into liquid. If I further decrease the pressure, it's going to turn into a gas. Okay. So if this is unclear, you can write it in a clearer way. So increase pressure, gas turns into liquid, liquid turns into solid, and decreasing the pressure, solid turns into liquid and liquid turns into gas. So observe, this is exact opposite of what you do with temperature. So if I decrease the temperature, then the red wala is going to happen. So decrease temperature, gas, liquid, liquid, solid. And increasing the temperature is going to turn solid into liquid and liquid into gas. So temperature and pressure basically have opposite effects on matter. So increase pressure or decrease temperature. And solid liquid gas के लिए decrease pressure or increase temperature. Hi Ashmi, good evening. Oh, you're not well. क्या हुआ? Do you wanna like take rest?
Hello.
Yeah, Ashmi.
Yeah, actually I'm not well at the moment. सर्दी हो गई है तो इसके लिए.
Summer में सर्दी हो गई. Take care.
हाँ. Yeah, maybe because of the AC at school. I don't know.
Oh, okay. But yeah, take care of yourself. Don't like,
Yeah, thank you.
Yeah, so we were discussing effect of pressure, like temperature increase करने पे you have solid turning into liquid, turning into gas. So pressure का effect is the exact opposite of it. So pressure increase करने पे gas turns into liquid, liquid turns into solid. Pressure and temperature act opposite to each other. So once you guys finish noting this down, let me know. We'll discuss the next.
But only the part increase pressure gas to liquid to solid or decrease temperature.
Yes.
That done.
Yeah. This is important. If you want, you can note this down if it will help you understand and all that. But yeah, knowing this is important. Increasing pressure se kya hoga, decreasing pressure se kya hoga. That part. Okay, Shnaya is done. Okay, Suhani, Yashmi, once you finish writing.
Done.
Done. Chalo.
We have to write everything, right? Mentioned here.
Na, ये दोनों like increase pressure, decrease pressure से क्या होगा? This conversion is important. Apart from this, if this will help you understand, note this down. Otherwise, it's not necessary. It's just visual representation of whatever you mentioned here. So.
Okay. Done.
Cool. Yeah. So apart from this, there is one more phenomenon related to matter, which is diffusion. We guys heard of this before? Diffusion क्या होता है?
Means it's like the spreading of molecules from a higher concentration to a low concentration.
That's basically it. Yeah, spreading. So क्या होता है ना, like particles. So one of the characteristic of particles, if you see, where is it? So सबसे पहले we discussed this, right? Characteristic of particles. Matter is made of particles. They're very small in size. Blah blah blah. So this is an important this thing. So particles of matter are continuously moving. So it's because of that movement that whatever space is available. So this is specially to gases, like क्योंकि gases में बहुत ज़्यादा movement होता है. Whatever space is available to the gas, they're going to occupy all of it. So as an example, suppose we have a big empty room. Okay. And you take a small box full of, let's say, oxygen gas or nitrogen gas or something, or it could be perfume, and make a tiny hole in it. So after some time, like iske andar gas ke molecules hai, they're constantly moving around, zipping around, whoosh, 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 idhar udhar. So some of them, once they find the hole, they're going to get out of the hole, and eventually this is going to occupy the whole entire space that is available to it. You're going to smell it completely in the room. So this process of this gas particles spreading around is called diffusion. So here's the definition. Process in which particles of one substance occupies the vacant spaces present in the particles of another substance is called diffusion. Here it specifies another substance. अगर वहां पे और कोई substance नहीं है, तो it's going to occupy whatever space is available in it. So even if there is air inside it, it's going to still occupy the spaces in between the air particles. So this spreading, this process of like occupying whatever space is available to it, so that is diffusion. Okay. So solid liquid may, so you don't find diffusion so much because solid may all the particles are very rigid, उसमें motion उतना नहीं होता है. Liquid maybe they're still close by to each other. बहुत ज़्यादा है intermolecular attraction. But in the case of gases, because they move around so much, gases have a tendency to diffuse a lot. But even within liquids, like if you have a tank of water, if you add 1-2 drops of ink in it, it's going to diffuse and occupy, like eventually that whole water is going to get colored, right? So that ink particles are occupying the space in between the water molecules. So that's diffusion again. So it's the nature of particles to occupy all the space that is available to them. So that's diffusion. Okay. So based on diffusion, I'll ask you guys a couple of questions. One is, again, let's take perfume bottle. Like if there is a perfume bottle that is open and kept in one corner of the room, why are you able to smell it from another corner of the room?
Because
Because the
diffusion of
particles
gases.
Okay, so Dhriti said diffusion. Shanaya, what were you saying?
I was saying the same thing.
Same thing, yes, absolutely. So you can answer, say, because of diffusion, the particles occupy or are spread out across the room, which is why we can smell it. Or you can say the particles of the perfume diffuse across the entire space in the room. That's why we are able to smell it. So use the keyword diffusion. Okay. Another question. Okay. Let's say I have 2 plates of food. 2 plates of food. This is plate A. This is plate B. So plate A, I just took it out of the fridge. So it is cold. Last night's leftovers maybe. Plate B also I took it out, but I put plate B in a microwave. So this is warmer, hot food. So if I put both of them in a room, which food will I be able to smell better? Food from plate A or food from plate B?
Food from plate B.
B.
Okay. Ashmi, what do you say? Ashmi, are you there? Plate A or plate B? Hello, Ashmi, are you there? Okay. But majority of you are saying plate B, which is absolutely correct. B is what you'll be able to smell better. But what is the reason? Why? Why did you say B? Yeah, Suhani? Oh, Shania said absolutely. Yes, that is the exact reason. Dhriti, Suhani, what do you guys say? Like, why did you choose B?
There's anything to do with kinetic energy.
Yes.
Kinetic energy is high.
Correct. So hot, more temperature, matlab more kinetic energy. So that's what we discussed last time, right? So more kinetic energy, matlab more movement. Kinetic energy is literally energy related to motion. So the particles in plate B, because they're at a higher temperature, they'll be able to move better, and so you'll be able to smell them better. Yeah, so that's another important point. Key diffusion increases with temperature. Like particles move with a greater velocity, they diffuse faster at hotter, like higher temperatures. Okay, so this is the concept, but the kind of questions you'll be asked is this, like application based questions mostly. Okay, cool.
Miss, could you once again explain latent heat?
Yeah, will do. Okay.
Thank you.
So iske baad, the only bit we have is evaporation. So we'll do latent heat and then we'll get to evaporation. I actually found a good simulation. So I can like just put that up. Done? Okay. So and Suhani is also finished writing. And Ashmi, where are you at? What's going on? Finished noting? Done. Suhani is also
Yeah.
okay.
Hello.
Yeah, Ashmi.
Done.
Cool. So we'll revise latent heat once. Okay. So this is the temperature time graph. Shania, are you familiar with the temperature? Like, have you done this?
Yes, ma'am.
Done, no? Okay. Okay. So let's start with solid. Let's finish up at gaseous state. So, here they're starting at minus 100 degrees Celsius. So, abhi glass mein pura, it's ice, frozen solid. Okay. So let's start heating it. So, okay, they started at minus 50. Temperature increases. As you keep heating, you can see that temperature constant hai. It is at 0 until all the ice has melted into water. Then पूरा melting खत्म होने के बाद then the liquid starts turning into, like, liquid का temperature will again start to increase. So now it's gone to 28, 29, 30, 30s में जा रहा है, still water, 40s में जा रहा है, then 50s में जा रहा है, 60s, 70s, 80s. So slowly you can see that motion is also increasing. It's getting faster and faster as temperature increases. Then 100 pe, again the temperature has become constant, but यहाँ पे steam has started going out. So this is boiling. So liquid is slowly getting converted to steam. यहाँ पे liquid का quantity is also decreasing because all of it is turning into gas. तो पूरा gas ऊपर जाने के बाद, if you still heat it, that particular gas ka temperature will start increasing. Okay, so this is the temperature time graph. Now, if you observe the gas, there are times where temperature is constant. So यहाँ पे you can see that this gas, like the glass is still on the hot plate, मतलब इसको heat energy दे रहे हम, but still temperature is not increasing. तो वो पूरा heat energy कहाँ पे जा रहा है? What is happening there? Okay, so where is that heat energy going? Because we are not able to see that heat energy, that particular type of energy is called latent heat. Yes, so Shania said it correctly. So that particular heat of energy, agar temperature change mein nahi ja raha hai, so this constant levels, where that heat energy is going is in phase change. So that energy is used to change the state of a substance. Okay, so depending on what is the phase change, you have different types of latent heat. So
the phase change is known as latent heat.
No, so the energy required for phase change is called latent heat. So latent heat is the amount of heat energy. Okay, so this is measured in joules. So energy, calories, joules hote hai na? Like that way, joules is the SI unit for heat energy. It's a physical quantity that you can measure. तो solid से liquid के लिए जब use हो रहा है, so that is latent heat of fusion. क्योंकि
This is the heat energy, right?
yes. And the energy that's used to convert liquid into gas, जब boiling हो रहा है, that is called latent vaporization. So it is the amount, so latent heat of, if you are considering fusion, it is the amount of heat energy that is used to convert a particular amount, like 1 kg of solid ice into liquid water, or 1 kg of solid into water. And latent heat of vaporization is the amount of heat energy that is used to convert 1 kg of liquid into gas. That's the definition. We have it right here. Yeah, there you go. In words, yeah. So latent heat of fusion is the quantity of heat. So this quantity of heat is measured in joules. It's not any random heat energy. The quantity of heat required to convert 1 kg of solid to liquid. And this conversion should happen at its melting point. इसलिए ice का it happened at 0 degrees Celsius.
Because without any change in temperature, as in the thing which is changing its state shouldn't become hot if it is turning into liquid. That
yes. So basically, this particular heat energy, we are counting only the heat energy that is used in changing state. अगर temperature change हुआ मतलब that heat energy was used in change in temperature, तो उसको count नहीं करना है हमें. So जब temperature constant है, without any change in temperature, whatever energy is going into this conversion, solid to liquid, या vaporization में liquid to gas, that particular heat energy is what we count under latent heat. लास्ट क्लास में लिखा था ना latent heat of fusion, latent heat of vaporization.
हाँ. But temperature change means that latent heat is used for temperature change.
Can you repeat that, Kriti?
If the temperature changes, then it means that the heat is being used to change the temperature, not to break down the molecules.
Yeah. So latent heat के लिए we only need to count conversion में कितना heat energy जा रहा है. Now we'll come back to this. Okay, now, okay, tell me when you guys are ready, then we'll start the next one. It's good you brought this up. So like evaporation also is related kind of to the engine state. So we'll do that. Okay, everyone done? So I need you guys to observe
Yes, miss.
this. So we have, I'm changing state from liquid to gas, and we can see abhi 50 degrees Celsius pe hai. Okay, so I'm gonna heat this water, and I need you guys to observe ये molecules को क्या हो रहा है. So now I've heated it only from 50 to 90 degrees. Matlab, water is still in liquid state only, but what did you guys observe? What was happening to the molecules here?
They were loosening, like, and they were like,
Yes,
the speed was faster.
correct. And I also said faster movement. Is there anything else that you guys observed? The process में? और कुछ पता चला? I'll replay this. So I'll just play this again, 50 say. They break bonds and move into the air. Yes, Shanaya. So if they're moving into the air, like beach mein you have random molecules going up, right? So that means that those molecules are basically turning into gaseous state. But that was happening before it reached 100 degrees Celsius. So क्या हो रहा है वहाँ पे? How are those random 1-2 molecules like just being able to escape in the atmosphere below its boiling point? So what was happening at that point?
This you're saying it was becoming vapor below degree.
Yeah, correct. So Shanaya caught it. I want to see if anybody else is able to identify what is happening there. Like, what do you call when a liquid turns into vapor at, if not at room temperature, like below its boiling point? Before it boils, only if it turns into vapor, what do you call that?
From liquid to gas, right?
Yeah. तो उस प्रोसेस, उस फिनोमेनन को क्या बोलते हो?
I evaporation.
Evaporation. Yeah.
Evaporation.
Have you guys heard? Okay, you must have heard of this word, this process before, right? Evaporation.
Yes, miss. Miss, evaporation and vaporization is the same thing, right?
Similar but not same. Okay. Vaporization, yes, but like boiling also is a type of vaporization. Evaporation is also a type of vaporization, but there are finer differences. So boiling happens only at a particular temperature, जब वो boiling point पे reach होता है. Evaporation takes place, like the only similarity both of them have is that in both the cases liquid is turning into gas, this conversion, but both are not the same. So boiling takes place at boiling point, evaporation takes place at all temperatures below the boiling point. कोई भी टेम्परेचर पे हो सकता है evaporation. Above the boiling point तो the natural state of that matter itself is gaseous, तो vaporize हो जाएगा. But this happens below the boiling point. Yeah. So that's like a very fine difference. That's a very important difference between evaporation and boiling. So before we compare both of them, I'll discuss a little more about evaporation. So evaporation happens below the boiling point. Evaporation is something that all of you guys have seen in your life since you were born. right? Like how do clothes get dry after washing? How do water spills dry up? So that is basically that happens because of evaporation.
Miss, evaporation is turning of liquid into gas below the boiling point. And
Yeah.
boiling is when the same thing happens at 100 degrees Celsius.
At boiling point, so there's like a formal definition for boiling. So boiling, you call it when the pressure of the liquid is equal to the vapor pressure. So basically, like liquid, the bulk of the liquid may the four intermolecular forces are less enough that it's equal to, okay, like it is turning into gaseous state. So evaporation is very different from boiling. Again, this is where the similarity ends, liquid to gas ho raha hai, that's it. So we'll dig deep into evaporation ki kya hota hai during evaporation, kyun hota hai, so that makes it clearer for you guys. Okay, so for that you need to zoom into a water container. So yahan pe, let's say there is water. So if this whole thing is filled with water, you have like water molecules everywhere, liquid particles here. The whole thing is filled with liquid particles, but abhi ke liye let's focus on the particles that are in the top row, like right on surface of the liquid, and the particles, like any one random particle that's in the interior. So let's focus on these two particles for now. Okay. Now all the particles experience, like हर एक particle के बीच में you have intermolecular forces of attraction. So if I focus on this particular particle, so this has this forces between these two particles, these two and these two, and these two. So what will be the net force on the particle that is in the interior? Net force क्या होगा? That's in the somewhere in the inside of this water container.
Miss, particles will move away. Miss, this is liquid, right?
Yeah.
No, Miss, I don't know.
Think about it. So net force, मतलब overall force कितना होगा? Like इधर से भी there's forces. So if I'm pulling, one particle is pulling from this side, one particle is pulling from this side. Overall force कितना होगा?
Acha, like that, Miss, it will be balanced out.
It would be balanced. So net force कितना होगा overall?
0.
So honey, yes. So this would be 0. मतलब overall force interior में जो है, they're just on their own. Overall force 0. They're not like being pulled or pushed or anything like that. But contrast this with a particle that's on the surface. कोई भी ये वाला random particle ले लो. Now this, okay, there's a particle on this side will be pulled easily, like equal opposite है. But the only forces it's facing is from the particles below it. ऊपर तो कुछ है नहीं, it's all empty space. So the particle on the surface is free to move because it has forces only from one side. Like there's attractive forces नीचे से, like this is also attracting the forces नीचे से ऊपर. Okay, so this is like free to move. इसके ऊपर net force is not equal to 0. Particle on the surface. Okay, so keep that in mind.
Miss, I didn't understand how is it not 0.
नीचे से all these particles are exerting attractive forces, but ऊपर कोई opposite force है क्या इसको balance करने के लिए? जैसे यहाँ पे था,
ऊपर नहीं
है ना? तो अगर आई एम पुलिंग ओनली फ्रॉम नीचे, तो force is not zero. Like there's nothing balancing
But
it.
means it's getting pulled from 4 sides, right? तो वो balance out हो जाएगा because there are even number of sides.
कहाँ पे? Like this side and this side will get cancelled out. But यहाँ पे जो force है उसका opposite कोई force नहीं है, और यहाँ पे जो है उसके opposite कोई force नहीं है. यहाँ पे क्या हो रहा है? This force is getting balanced by this one. तो ऊपर जितना pull कर रहा है नीचे भी pull हो रहा है, so both are getting balanced. ठीक है? This is getting balanced by this. This gets balanced by this, and this gets balanced by this. So all the directions, it is surrounded by molecules to balance it out. But that's not happening on the surface, क्योंकि इसके ऊपर कोई molecules नहीं है for intermolecular, नीचे ही है. ठीक है? So because forces are not equal, this is basically like free to move. थोड़ा इधर उधर थोड़ा move करेगा. Keep that aside. Now as it is moving, like थोड़ा इधर उधर collide हो रहा है, so इसका velocity, you know, it increases, it decreases, depends on how it is moving and how it is colliding with other molecules. At one point, now this will not happen with all of the molecules. One random molecule will get enough energy because नीचे से भी forces है, like all of these are colliding against it, so it will get enough energy that it will escape out. It'll get enough kinetic energy that, you know, it is sufficient to escape these forces and get out of liquid state. Yeah. So because this is very randomized and it is happening only to some random molecule on the surface, so all of it is not getting out at the same time. So you saw it from the simulation, right? Randomly one will get out here and there. So that is what is happening during evaporation. And that is the reason evaporation, like boiling to immediately ho jayega. Like you put heat 15-20 minutes and then water will start boiling. But evaporation takes hours and hours. Like if you lay out some kapda for drying, it's going to take 2-3 hours for it to get dry. And that too, it depends on like temperatures and all of those other things, right? So that's another point of difference about evaporation and boiling. Evaporation is a surface phenomenon. So it liquid to gas below the boiling point, also it is a surface phenomenon. So under jo molecules hai, they will never get out. They will never get enough energy to go into gaseous state. It will affect only the molecules on the surface.
But after some time, can it affect the lower molecules?
Yeah,
After.
like move karte karte, if this gets on top, again, the conditions on top
But
are...
the first priority is the first layer, kind of.
So whatever molecules are on the surface, it could be this molecule, like all molecules are in motion, right? If it eventually gets to the surface, it will happen. The point is, agar koi molecule andar ki taraf hai, that will never ever evaporate. Only the surface molecules are going to evaporate. And because it's like one layer at a time, evaporation takes a lot of time. So imagine if you spilled water like on the floor or on the table, agar naturally dry karna hai, so it's not going to happen all at once, right? Pehle, like it takes like hours and hours. It's a very slow phenomenon. Okay, so evaporation ka definition, hang on. Like if you want, you can note these points, but note down the formal definition of evaporation.
This is fine, madam. Noting this down.
Okay. Again, if this helps you understand and remember evaporation mein process mein kya ho raha hai, like note it down. Otherwise, something that will help you write the answers, something that will give you the keywords, take it down from the chapter notes. If you want, I'll display it here, or you can note it down from the book. Now, because it's a surface phenomenon, because अभी क्योंकि समझ में आ गया evaporation में क्या होता है, so we'll look at what affects evaporation, what increases, what decreases, all that stuff.
There's a definition of evaporation which is on the first page, right?
Yeah. Yeah. The phenomenon of change of liquid to vapor state at any temperature below the boiling point is evaporation. Shania, share the module matlab. So this class recording will be uploaded on the YouTube playlist. I think should be there in the group description. If not, you can check like Y Academy channel pe rahega wahan pe. And chapter note workbook, like the resources will be shared. So if you're joining, yeah, so you'll have the soft copies, and once you join, then we can send the books for printing, and all of this will be shared with you. Okay.
Done, miss.
So honey also done. Ashmi, finished writing?
Done.
Okay. Shana, you finished writing? I can only see like till your forehead. I don't know if you're writing or if you're finished.
No, I'm finished.
Okay. Factors affecting evaporation. Abhi, what speeds up or slows down evaporation? The first thing is very obvious. It's a surface phenomenon, right? So how do you think surface area will affect evaporation? Agar surface area increase hua, so will it increase the rate of evaporation, decrease it, or will there be no change?
Increase the rate of evaporation.
Increase is evaporation, absolutely right. So if surface area increases, evaporation also increases. That's pretty obvious, right? Agar zyada surface mila hai, to more chances for the molecules to evaporate. अगर कम surface area है, अगर छोटा सा है, तो very less molecules will be available to be able to go evaporate. Okay, so surface area direct relation है. So if you increase the surface area, increases the evaporation. Can you guys tell me what is the application of this? Like, how do you use this in real life? कि surface area increase करने पे evaporation increase होगा.
We spread out the clothes more.
Yeah. So when you're drying clothes, do you fold it and like put it somewhere, or do you spread it out? So spreading out से क्या हो रहा है? You're increasing the surface area. You're like exposing the whole surface of the clothes to dry it out instead of like bunching it up together. Okay. Next, temperature. How do you think temperature affects evaporation? So again, if we increase the
Increases evaporation.
increases evaporation, yes. Explanation again, this also. So if temperature is already high, it means that the motion of the molecules is already high. So it doesn't take a lot in order to get it to the vapor state. It's easier for the molecules to evaporate. And where do you see this in real life?
When it is more hot, the clothes dry faster.
With more sunlight, they dry faster.
Yes. Hotter days, easier drying, colder days, they don't. There you go. Next, wind speed. How does wind speed affect evaporation? अगर wind speed ज़्यादा है, तो evaporation will be
It will be higher.
higher. Suhani, do you agree?
Because evaporation would be lower, lower rate.
Lower. Okay. Opposing answers.
Lower.
Okay, can you guys give me your explanation? Why do you think higher? Why do you think lower?
Higher because the wind has the air has a certain capacity to take in molecules of water. So when wind comes, the air gets moved away, and there is more space for more particles of water. So it increases.
Okay, and why do you guys think it's lower?
Yes, because it somehow affects the temperature. But I'm not really sure, but I feel evaporation rate would be lower.
Yeah,
Don't go by
the
me.
wind speed is high. It would affect the temperature, right? So maybe that's why.
So here we are not considering temperature at all. Like temperature 30 degrees here, we're just considering wind speed. Okay. So don't confuse it. Like एक criteria की वजह से don't think that that's going to affect something else. So whenever I say wind speed ज़्यादा है, you might start getting cold, rainy, stormy days in your mind. But don't think of it in that sense. Okay, let's say you have like you spilled water on yourself. You have two options. Either like let it dry naturally, like ऐसे ही रख दो, eventually it's gonna dry out. Another option is put a hair dryer on it, on the wet spot. Which one would you prefer?
Head.
क्यों? Hair dryer क्या कर रहा है वहाँ पे?
Wind. हाँ मैं वैसे ना like सूख जाएगा वैसे wind helps in faster rate of evaporation.
Yes. So when wind speed increases, evaporation also increases. Yeah. So the reason Shania has summed it up, but the last bit is a little incorrect. So what happens is wind speed zyada hai matlab, yes, molecules like air molecules have a lot of wind speed, so they're going to move faster. Now the surface is in contact with air, right? So if wind is faster, so these air molecules can come in contact with water, and when they collide, there is a possibility that they give greater velocity to the water particles because of those collisions. It's not like the air will come pick up the water molecule, but it's more like, so imagine if there's a cycle going and someone like pushes it from behind, the cycle's gonna go faster, right? So that's kind of the effect that the wind molecules might give to the surface molecules. So wind speed zyada hai, matlab these particles have greater velocity. So when they collide against water, they might give part of that kinetic energy to the water molecules. So extra energy matlab evaporation bhi aasan ho jayega. So that's kind of how the wind speed affects it. And application, yes, windy days, as long as it's not rainy. Okay, so if you're considering only the wind, it gets faster, and you apply it in your everyday life. Like, agar kuch, if something needs to dry, you start putting it under the fan or you put hair dryer over it, right? So what are you doing? You're trying to circulate the air. You're increasing the wind speed artificially so that it can evaporate faster. Okay. And finally, the fourth is humidity. Do you guys know what do you mean by humidity before we start discussing evaporation?
There's more of vapor in air. It's like, yeah, more of vapor in air.
Yeah, so humidity, it's not more or less, it is the amount of water quantity in air. Amount of water vapor in air. Okay. So you have more humidity, yes, more water vapor in air. Less humidity, matlab less water quantity in air. Okay. So how do you think humidity is going to affect evaporation?
Evaporation will decrease.
Yes. Humidity agar zyada hai, so evaporation will decrease. You've seen this in your real life. Like rainy days mein clothes will barely dry. It's going to take 2-3 days for clothes to dry. Okay. And the reason being, okay, like, see, usually at a certain pressure, air has a capacity of holding only a certain number of water molecules. So if air already has that, like a lot of water molecules in it already, let's use a different color. अगर atmosphere में already काफी सारा water molecules है, तो like even if one evaporates, there's a chance that one existing vapor molecule can go into liquid state. So that's why अगर humidity ज़्यादा है तो rate of evaporation decreases. So part of the reason is that air has like a maximum capacity of holding X number of molecules, water molecules, एक temperature पे. If it's already like filled with water vapor, it'll hesitate to take more. So these are the basics. So like evaporation pay, you might get questions based on what is evaporation, how it happens, and factors affecting evaporation. Either you'll be asked a direct question, ki what are the factors affecting and how does it affect evaporation? Or you might be asked like an application based question, like the cases that we have discussed. Agar evaporation zyada hona chahiye, they'll give you a situation. Drying clothes, maybe drying your hair or like whatever it may be, and then they'll be like, if we need this to be faster, then what can you do about it? So either you can increase the temperature, increase surface area. Like if you want, like suppose chai or coffee that you drink is too hot, if you want to cool it down faster, what can you do in order to cool it down?
Blow air.
Blow air. So you're basically increasing the wind speed. What else can you do?
Because you want to cool it down. But sometimes like we take 2 containers and then we start pouring it in one another. So basically it's like wind circulation.
Surface area. So you can put it in a saucer and then like blow air on it. You're increasing the surface area, cup se saucer. Even putting it in two containers, like if you increase the space between the containers, like again, more surface area and also the wind speed, so that like cools it faster. You can put that cup in a container of cold water, like take a bowl, shallow bowl, have like ice cubes or cold water in it and put it there. So you're decreasing the, I mean, that's not related to evaporation. You're just directly decreasing the temperature, so that not work. So like surrounding the temperature, you can't control the weather, so you can't do anything about temperature or humidity. But yeah, surface area, wind speed, you can absolutely control it. Yeah. So questions like that. Yeah. And finally, like some major differences between evaporation and boiling. Again, remember evaporation, boiling, the only like similarity is that the change of state is liquid to vapor. But everything else around it, kyun hota hai, kaise hota hai, all of that is completely different. So boiling, first point, it occurs only at a particular temperature, which is called the boiling point. Evaporation takes place when it's placed in an open container at any temperature below the boiling point. Boiling is a bulk phenomenon. Evaporation is a surface phenomenon. Iska meaning kya hai? So surface phenomenon, we already discussed. Only the molecules on the surface are capable of evaporating. Bulk phenomenon, what it means is that if you've ever seen water boiling, niche se you have like bubbles coming up, right? So even the particles that are inside in the bulk of the container get enough energy to get converted into vapor state. So the whole water in the container as a whole, as a bulk, it is capable of converting into gaseous state. So that's why it's a bulk phenomenon.
Because then at the end there would be nothing left in the
Yeah.
container. Everything would have replaced.
Yeah, like all of it boils together, if you heat it for a certain amount of time, 15-20 minutes, depending on how much water you have. Heating takes place during boiling because you need to raise it to that boiling point, otherwise it won't boil. And for boiling, generally heat from an external source like a burner is required. So boiling ke liye, you need to especially put it on a fire. Evaporation, koi heat nahi chahiye. Like that's why it takes place at any temperature. Cooling takes place during evaporation. Okay, so this is another important point. Okay, so evaporation mein kya ho raha hai? The surface molecules are basically taking energy from the surrounding molecules. Remember when I said as they move, thoda idhar udhar collide hoke, if this particular molecule gets extra kinetic energy, it's going to get enough kinetic energy to go out. So that extra kinetic energy kahan se mil raha hai? It's getting it from the surroundings. It could be other water molecules. It could be like the surface of the container. Wherever it is getting from an external source. So agar surface say if it is taking out kinetic energy, or like if it is taking out energy, wherever it is taking it out from, uska temperature thoda kam hoga. So that's why we say cooling takes place during evaporation. Like if you had to imagine it, suppose you're sweating a lot, or if you just washed your face, fan ke niche baithne pe, how do you feel? Like as the water evaporates from your skin? Cold, right? So that's the cooling effect of evaporation. So if this is your skin, agar iske upar there's like a thin layer of water, abhi ye water molecule ko evaporate hone pe, it needs to take energy from whatever is around it. Now because it is taking away energy, you're feeling that as a cooling sensation. Heating is you're adding heat energy. Cooling is the opposite, you're taking away energy. So that's why evaporation may always it like cooling effect accompanies evaporation. So for evaporation, liquid takes heat from the surroundings, which will result in the cooling effect. And because it's anyway taking it from the surroundings, you don't need any heat source for it. You don't need to put it on a stove, flame, burner, and all that. Okay. So these are like major important points about evaporation and how it compares with boiling.
Miss, do we have to make this table in a notebook?
You can do it after class because it's there in your chapter notes. Points of differences, it is important to know. If you want, you can we can do it after class. Like you can get started. With
Miss, if I highlight it in the book, is it fine?
I
should I
need you
do
to write it at least once.
Okay, I highlight it.
So
Okay.
writing is better for learning than just reading or going through it. So at least once, yeah. Okay. So once you finish, ready for the next part, let me know. Shnaya is done. Okay. So Dhriti, Suhani, Ashmi, tell me once you've finished. We'll get the others.
Yes, miss. You have to make the table after class.
Okay. Okay, so that's the end of the chapter. That's all we have. And since we're doing states of matter, let's talk about plasma and Bose-Einstein condensate also. Now, this is not usually counted when we talk about states of matter, like increase in temperature, increase in pressure, and all that. Because they are not very practical, honestly speaking. ये तो बहुत ही extreme states of matter है. Okay. Okay, so once you're all finished, then I'll discuss plasma and BEC. And we can do a few questions. We have time for that.
Done.
Cool. Ashmi is finished. Swani also looks like she's done. Cool.
Done, miss.
Okay. So, all right. So you've learned about solids, liquid, gases. Now, So now let's take it to one extreme. So liquid से vapor करने के लिए you heat it, and then the movement increases a lot. Liquid turns into gas, and then let's say you just keep on heating it. Gas molecules का temperature और भी increase हो जाएगा. Like motion will increase a lot. Then if you keep on increasing the temperature, abhi, like if you consider water, uska boiling point is 100 degrees Celsius, right? So if you keep increasing, uska temperature also will keep increasing. Let's say you increase the temperature to almost like 6,000 degrees Celsius or something like that, in that range. So what happens at those extreme temperatures is, तो gas molecules भी stable नहीं रहेगा. Like any atom or molecule will not be stable at that point of time, at that temperature. तो इतना energy है कि forget about intermolecular attraction. So that energy is even enough to break the molecules apart. So what happens in those stages is, so atoms are made of protons, neutrons, electrons. Familiar with it? So when you provide enough heat energy, so those protons, neutrons, electrons, whatever holds an atom together, that itself breaks apart, and you kind of get a soup of ions and electrons and all these subatomic particles. So that soup is what we call plasma. So that is plasma state. Okay. And because you need such high temperatures to like create plasma or let some matter be in plasma state, earth pe kahi, like you don't find it anywhere on earth. It like extreme laboratories may, specific conditions may you can create it, but naturally you won't find it. So this is the stuff that stars are made of. If you look inside stars, it's just a mess of, you might find hydrogen, helium atoms, but beyond that, it's just random electrons and ions and all of these energetic.
So, Miss, where do the ions come from? Is it a breakdown of
Yes.
electrons?
Yes. So let's say we have oxygen atom. So say if you take away electrons, negative charge nikal rahe hai na? So what is left is the positive charge. So that's an ion. Yeah, Shana is saying sun. Like the middle of, like center of the sun, what is sun made up of? It's made up of hot gases, yes, like hydrogen, helium. It's also made up of plasma, which is basically made of all these ions and subatomic particles. Okay, so that's one end, one extreme of it. Like you have solid, liquid, gas, and if you keep on increasing the temperature to its extreme, what you get is plasma. Okay. Some fun facts about plasma. Let's get back to this. Mixture of free electrons and ions. Yeah. Stars. Yes. Because of extremely high temperature, atoms break down. They break away. And yeah, sun and stars glow because of the presence of plasma. It's an extremely high energy state. Enough energy that you can see that energy coming off of it in the form of a glow. So on Earth, as I mentioned, right, laboratory, like by taking that specific conditions, you can create plasma. How you create it? Technically, it is made by passing electricity through gases. You take gas at a very low temperature, pass electricity through it. Because of that energy, the atoms, like the electrons get ripped away from the atoms and you get ions and you get plasma. And this is how lights are created: fluorescent tubes, neon lights, all of that. Okay. You can create plasma at home, although I will not advise you guys to do it. Let me see if I can find that video. The fun thing. There you go, plasma. I'm not sure. There's two ways of creating it. I'll show you guys. You don't need to note this down, like examination point of view. Say if you want like the important bullet points, you can just make a note of it, but exact keywords and all you don't need to. I don't know if this is even there in your textbook or not. Maybe it's there in a box or something. But yeah.
In the school NCRT.
Mm.
Yeah, it's given as like an extra information, but you have to study it.
Oh, okay. Nah, like it's not. I've never seen any question based on plasma and all, so you don't have to worry about that.
Then I'm not sure.
Yeah, this is a half an hour long video. Okay, this I'll send you guys a link to this video. You can watch it in your own time. But the grape one I have heard of. Like ये बहुत पुराना video है. So I can like show you guys that. Again, comes with a disclaimer that do not do this at home. You're gonna break your microwave and your parents are gonna be annoyed with you. So don't do it at home. There you go, warnings right here. Yes.
In temperatures as hot as the sun, plasma exists in a fourth state, not solid, not liquid, not gas, but in a state where the electrons wander away from the nucleus. Plasma is a state of matter similar to gas, in which a certain portion of the particles are ionized. Heating a gas may ionize its molecules or atoms, thus turning it into plasma, which contains.
So what they're doing is they're trying to simulate the condition under the sun. So they're already heating up a gas by putting a flame inside. And when they switch on the microwave, that microwave radiation itself has extra energy. So that's how they're trying to create plasma inside here. Okay. You guys are still noting this down. So once you've finished, then I'll play this video. Yeah. Ashmi, Shanaya, should I start? You guys ready?
Yeah.
Okay.
Charged particles, positive ions, and negative electron ions. Ionization can be induced by other means, such as strong electromagnetic fields applied with a laser or microwave generator, and is accompanied by the dissociation of molecular bonds if present. Plasma, therefore, has properties quite unlike those of solids, liquids, or gases, and is considered a distinct state of matter.
So they're heating up the gas inside here.
That was awesome. I don't want to touch that.
Yeah, what they created there, like when it went dark and you had like a heated bit of glow here. So that was plasma. What happened is by putting the matchstick, by putting the flame inside and putting the beaker over it, yahan pe they already heated up the gas to a high temperature. And beyond that, because the microwave radiation was applied to it, like that's the energy that heats up your food, right? और इतना ज़्यादा एनर्जी होता है माइक्रोवेव में, इमेजिन लाइक अगर वो स्टोव टॉप पे करना है तो इट टेक्स अबाउट 15-20 minutes to boil water, but वही माइक्रोवेव में it happens in 1-2 minutes. So that's the amount of energy that you're supplying. So already heated gas ko, since you're giving it energy, it's sufficient to break the molecules here and create that plasma. but yeah, that's essentially what they're doing. They're giving it so much
But
energy.
then miss, it stays for like only a couple of seconds, right? In the microwave.
Yeah, there's like whatever time you put this timer.
Miss, but then how does it stay for so long naturally in the stars? Sun?
You know the size of the sun, like कितने सारे atoms, कितने सारे ions, कितना सारा heat है उसमें.
That is used, but फिर भी.
And that is the reason stars also have an expiry date. Like because they are so massive, it doesn't mean that they're around forever. So इसलिए you have
They die.
and black holes and yeah, stars do die. So that means उनके लिए भी that energy gets over at some point. It's just that it's way beyond our life scale. Another way of doing it is by doing it from grapes.
So when this channel was fresh and before I had gray hairs in my beard, in fact, before I had a beard, I made a video showing that if you take a grape and cut it almost completely in half and put it in the microwave, you can make some plasma.
Oh, go the laws of physics.
Yeah.
Oh, yeah, it's still going.
But the explanation we had in that video was lacking. This was me and my friend Dr. Stephen Bose, a fellow physicist.
So you should look forward to that on another episode of Veritasium.
To be honest, nobody really knew how this effect worked. That is until now. As of the publication of this video, 3 scientists have published an explanation in the Proceedings of the National Academy of Sciences. They studied this effect with high-speed cameras, thermal cameras, electromagnetic modeling, and they came up with an explanation that I think is pretty satisfying, and it extends way beyond just microwave grape plasma. So naturally, I called up these scientists.
Yeah, I actually saw your video before, like your videos before joining the Great project.
Oh, really?
Yeah, so I was like already kind of like interested before joining the project.
The scientists showed you don't even need to use a grape. You can get the same effect with hydrogel water beads. These are those tiny polymer beads which when you soak in water, they increase in volume like 100 times. To understand how microwaving a grape gives you plasma, we first need to know a few things. Like a typical household microwave uses a frequency of electromagnetic radiation at about 2.45 gigahertz. That means that the wavelength of microwaves inside the oven is about 12 centimeters long. Now, if you've ever studied electromagnetic radiation, you might have the intuition that interesting things start to happen when the object or obstacle is around the same size as the wavelength, which a grape certainly is not. It's not 12 centimeters. But the important quantity is how big is the wavelength inside the object, inside the grape. 12 centimeters in air,
Okay.
but the like index of refraction of grape material must be.
This is going into concepts that you guys have not come across, electromagnetic radiation and refraction and all. So don't worry about it right now. Refraction and all that grade 10 mein hoga when you study about light, and then electromagnetic radiation, like that's the basics. 11th May first chapter itself, you pick that up. So don't worry about that at this point. That's why we're not going too deep into plasma also. I thought I'd just like show how like a visual of what plasma is and how it is made and all. Essentially, it's an extremely high energy thing. Itna सारा energy hai ki it like literal atoms break down with that energy, which is what is creating plasma. That's the main point that you need to know. Then apart from plasma, another state of matter is Bose-Einstein condensate, BEC. That's also again discovered very newly. Pehle it was theoretically known, but practically it's not done like until recently. So 1920 mein theoretically Indian physicist S.N. Bose had done calculations. So theoretically they were like, okay, if I decrease the temperature to this extent, फिर atoms molecules को क्या होगा? So by doing the calculations, he predicted कि there will be a state of matter, Bose-Einstein condensate. So like observing at laboratory में approach karna, it was done much more recently. So essentially, plasma is if you increase the temperature to an extreme extent. BEC is the other end of the spectrum. If you decrease the
Low
temperature,
temperature.
extreme extent, then molecules are all huddling together, right? So at one point, they're gonna huddle so close, and they like solid se bhi zyada, they form something called Bose-Einstein condensate. So extremely low density massive. That's the thing. So that's it for we looked at the two ends of the spectrum, and but the main thing you guys need to focus on is what happens in middle, the solid, liquid, and gas, because that's what you'll work with, come across in real life majorly. Okay, and everything that we study about abhi se 9th, 10th, 11th, 12th May, it's all going to be in solid, liquid, gas. So that's what we care about most of all. Okay. All right. All of you have guys, you guys have Flipper downloaded and set up, right?
Yes.
Yeah. Okay. So फिर I'll assign the thing. Like I would take a live session abhi, but there's some changes that is happening. They're going to roll out some updates. So abhi it's not working completely. It's not functional. So what you can do is I've assigned it as a homework. If you open Flipper app, हमारे urgent chapters में दिखेगा. So you can just.
Miss, that day, Lohit sir also told us to do the urgent homework. So, Miss, I completed a bit of stuff, but in my profile, homework completed was as it is. Like it was showing the same number from when I started and where I ended.
Oh.
It was showing only 14%.
Okay, so I'll inform the developers about it. Okay. So if you can take a screenshot or something, I'll that'll help. That'll be better. Try it again. I think that thing is sorted. Like somebody else also different grade may was facing that issue. I don't know if it's like a individual account level that issue is, or if it's the app ka update se ho raha. Try it again. Abhi chemistry bhi करके देखो. If it is still not changing, let me know. You can message on the group, or you can message me or Lohit sir, and then we'll get that sorted out.
Okay. So, Miss, are we doing a live session right now?
Not at the moment. Live से कुछ problem हो रहा है. So you guys can do it. Okay. Again, as always, any issue you're coming across, take a screenshot or do a screen recording and inform us so that